In this video, we're going to be looking at expected frequency and relative frequency. So expected frequency, this is your probability multiplied by the number of trials. So let's say the probability of a biased dice landing on a 5 is 0.25. Estimate how many times the dice will land on a 5 if it's spun 200 times. Okay, so we're told that the dice is biased, so it's not fair, so it's landing on the 5 more times than it should. So the probability is 0.25. Then we're just going to multiply this by the number of trials, which is 200. So that is going to be 50. There's our answer. Okay, next one then. So Chris has a biased coin. The probability that the biased coin will land on a tail is 0.3. Chris is going to flip the coin 150 times. Work out an estimate for the number of times the coin will land on a tail. Okay, so again, our probability is 0.3. Multiplied then by the number of trials, which is 150. Now, this is equal to 45. Okay, so now if you want to pause the video and try questions 3 and 4 yourself. When you want to see the answers, press play again. Okay, let's see how you did. So for question 3, we had 2/3 multiplied by 300, which gets us 200. For the fourth one then, 0.5 multiplied by 350 equals 175. Okay, and that's expected frequency. Now, relative frequency. So relative frequency is basically the exact same as probability. Your successful trials over the total amount of trials. So if you look at this question here, we're given a frequency table, and then relative frequency is just your frequency as probability. So we're told that Fred records a colour of 100 cars that pass his house. So that's our total straight away. So then for part 1, let's get the relative frequency of each of these colours. Okay, so the first one, 10. So 10 over 100, just like that. Then we'll have 15 over 100, 38 over 100, 32 over 100, and finally 5 over 100. Now I could have changed these to decimals as well, or even percentages, because remember, probability can be written as fractions, decimals, or percentages. Now for question 2, so this is an expected frequency question. We're told on an average day, 3,500 cars pass Fred's house. Based on his results, how many of these 3,500 cars will be silver? Okay, so our probability of silver is 38 over 100. Multiplied now by 3,500. Okay, and working this out, so I'm just going to do this fast. So 38 over 100 times 3,500, that'll be 1,330. Okay, let's have a look more. So this one here, so we have an 8-sided spinner, and then we have all the scores here, how many times it lands on each number. For part 1, we need to use the results to work out the frequency of landing on the 4. So now the first thing I'm going to do is get my total. So I'll add up all of these numbers. That's going to be 772. Now for 4 then, that's going to be 70. So for the relative frequency of landing on the 4 is going to be 70 out of 772. Okay, then the next question we're asked, is the spinner fair? So now if the spinner is fair, it should basically land on each number relatively to an equal number of times. It won't be exact, but it'll be around the same number. Now we can see there that it's landing on 6 way more than any other number. So we'll say that no, it's not fair, as it lands on 6 much more times than any other number. Okay, we'll do one more. So here we have a 4-sided dice, and then first part there, we need to use the results to estimate the probability of scoring more than 2. So the first thing we'll do is add up all of these. And that is going to be 400. Now the results to estimate the probability of scoring more than 2. So more than 2, we can have 100 and 104. So we'll have 100 plus 104, which is 204. And we'll put that over 400. And there's our answer to the first part. Now, if you want, you can simplify that as well to a decimal, to 0.51. But leaving it as a fraction like this is also fine. Now, for part 2, we're asked, is the dice fair? So looking here, if it's fair, it should be close to 100 for each one, because there'd be a 1 in 4 probability for each number. So I would say that yes, this is fair, because all of these values are pretty close to 100. And since all the values are pretty close to 100, they all have a probability pretty close to 0.25. So you can see I've worked this out myself here. So all of these are pretty close to 0.25, so we'll say yes, the dice is fair. Okay, any questions, please leave in the comments. Thank you.